recording, and it should be recording right now. Yep. Okay, so it's recording, and let's go ahead and start. So they start off with, this is the main thing, getting equations. We'll be getting equations in the form like y equals mx plus b, where m is the slope and b is the y-intercept. That's just one of the key things you hear in all sorts of algebra classes, is that type of thing. And so the slope, a lot of people have trouble with the slope. That's just how quickly things are rising, you know. So that's what they're working on right here. So on this first problem, it says every 4 weeks, a baby whale gains 100 pounds. This reflects a slope of, and it says, make sure your slope is a reduced fraction. Okay, so this has to be a reduced fraction. So what's it going? It's going up 100 pounds every what? 4 weeks. Well, 100 pounds every 4 weeks, when you think about this, its weight is going up 100 pounds every 4 weeks. Well, that's not a reduced fraction. So right below, they say rate is reduced fraction. Well, 100 over 4 reduces down to 25. So that's the same as 25 pounds every 1 week. So it's that ratio that they're working on there. So we need to write as reduced fraction. That'd be 25 pounds every 1 week. So there's a lot of examples on those. Like this particular problem, I think there's 7 different scenarios in there that could show up, but they're all like that. This is not a hard problem. So let's take a look at this one. On 2, it says Vanessa visits different states every summer. This summer, after traveling for 3 days, Vanessa has visited a total of 14 states. Then at 6 days, Vanessa has visited 23 states. What is Vanessa's average rate? So what we're talking about here on this example is another slope thing. It's a rate, so many per so many. So what it is so many states that she visits per day. So this is going to be something like, how many states does she visit? Let me write this down here. How many states per day? Well, let's check it out here. After 3 days, she visited 14 states. So let's just keep track of it. So down here, I'll keep track of it. 3 days, she visited what? 14 states. So this is days. This is states. And then it gave you another bit of information that after 6 days, she visited 23 states. So I'm just writing these as an ordered pair, days and states. So how could I figure out how many states per day? Well, let's see how many states, how much has changed. She went from 23 to 14. So I'm going to take 23 minus 14 to get how many additional states that she visited. And let's see how many days have gone by. So let's see, she was up to 6 days and she started at 3 days. So if I work this out, 23 minus 14 is 9. So now what I've got here is a ratio that she visited 9 states in 3 days. 9 states and 3 days. So do you see how I calculated that? I found out how many additional states she visited. Well, 23 minus 14 is 9. And then how many days have gone by? Well, she's at day 6 here. She's at day 3 here. Just subtract those and I get 3. Now just reduce that fraction down a little bit and you get 3. So it's 3 states per day. And there are people that are like that. They like, I want to see every state in the country. So they drive around and, you know, do that sort of thing. It's actually a real thing that people do. So 3 states per day. And you see, we didn't really, it's just kind of common sense working it out. But really what you're calculating on both problem 1 and problem 2 and a lot of other problems is the slope. How many per how many type of thing. So that's how that works. So this is going on here too, and it's kind of fitting that we're doing these problems now because, you know, it's getting close to Christmas, the holiday season, that sort of thing. So you'll see some Christmas problems. And Brittany, you'll see some Christmas problems, not on homework 10. I see that you clicked on that in the other class, in the elementary ed 306 class. But the next homework assignment, which I sent out an email today on, has more Christmas problems on it. So here's question 3. It says at 12:11, there were 363 dolls ready for sale. Well, let's keep track of it. Here's a time. At 12:11, there was 263 dolls. So that's a time of day, the 12:11. There was 263 dolls ready. Then at 12:20, see, it doesn't hurt to write some of this stuff down to keep it organized. There was 470 dolls ready. Okay, so this is like the last one with the states and the amount of days, dolls and the amount of time. A lot of time, the variable time is in there, like whether it be days or weeks or minutes, you'll see that. And that's usually on the denominator type of thing. See, weeks, day, and minutes, they're going to be down there. So it's the same type of thing that we're going to do here. And in fact, they even tell you the format here, dolls per minute. So we just do the same thing we did above. We take the 470 minus the 263 dolls to get how many more dolls were made. And then you do the subtraction in the amount of time. Well, we're taking the time of 12:20 and subtracting off the time of 12:11. Well, if you do this up here, you get 207. And if you do this down here, you get 9. The only extra thing that they say is to reduce these fractions. Actually, this one doesn't say reduce the fractions. We could reduce the fractions and it wouldn't hurt, but since it doesn't say it, I don't see it saying it. I think we might be okay to just go ahead and type it in. Let's try it not reduce and see if we still get it. 207 over 9. And let's see. Yep, this one didn't say it had to be reduced fractions, so I got it. What this means is that every 9 minutes, these elves or whatever they are, you'll see that on some of these problems, like elves are making something, is going up by 207 dolls every 9 minutes. So, yep. Okay, now just strict problems. Now we're going to some procedures and stuff like that. But notice we started off with the real life problems, whether it's about whales. I guess elves aren't quite real life. They didn't really say elves on that problem. But we did some application, real problems, nice thing to start off with. And then we're getting into just straight procedural problem. I don't like them a whole bunch, the straight procedural problem, but it's definitely nice to start off with real life stuff like we did. So this is just saying, get the slope of this thing. We could graph it too, but anyway, on this, we're at this point, we have the point 3, -6, and we have another point. Let me write it down here. The other point is 11, -2. And we know that slope, by the way, they use the letter M for slope. Not like everybody does that, but a lot of people use the letter M for slope. And the reason is because of business applications in which you get the marginal profit, the marginal cost and stuff like that, M for marginal. So it's kind of stuck around. So now you might say, well, we need to get this ratio. That's what slope is, something over something. It's a ratio. Now, what goes on top? Is it how much the y's have changed or how much the x's have changed? Well, it's rise over run. And when you think about graphing something on an x and y axis, you rise along the y axis. So the rise are the y values. So you subtract the y value. So let's do that. So here's a y value, -2. And I'll subtract off my other y value, which is a -6. So I'm putting that in parentheses just that you can see that I got 2 negatives there, which is eventually going to become a positive. And that's over the run. Now, if I started off with the -2 to subtract off the -6, then when I'm subtracting off the x's, I have to start over here, the same place I started off with the y's. See, I started here, -2 minus a -6. Now I got to do the same thing here, 11 minus 3. See, just like I did the subtraction on all the earlier problems, that's what we got to do here. So what's -2 minus a -6? Well, 2 negatives make a positive, so this is the same as -2 plus 6, and -2 plus 6 is 4, and 11 minus 3 is 8. Now this one says write it as a reduced fraction, and 4/8 reduces down to 1/2. And that would be it. That's the slope there, 1/2. You can graph these as well and just count how many points it went up. So that's another way of doing it there. Okay. So this one wants the whole equation here. So this one's a pretty rough one. So you might really want to have this one as example, but you can see that this one has both a video and a written example on it. So here we go. Here's my 2 points. One point is at 978, and the other point is at 546. So the first thing we're going to do, see, there's 2 parts to get in this equation. You got to get the slope, m. So we're going to do that first, and then after we do that, we're going to get the y-intercept. So you do it in that order, get your slope first, then get your y-intercept. Well, the slope is how much it rises. So I'm just going to subtract the y's first. Now, I could take 46 minus 78, but that would lead me to a negative number. So I could do that if I wanted to. But I'm looking at it, I'm just saying it's easier for me to take 78 minus 46. So if I subtract the y's in that order, then I got to subtract the x's in the same order, meaning I got to start off with a 9. So 9 minus 5. So it's just an easier order to subtract. But guess what? If you do it the opposite way, if you take 46 minus 78, then on the bottom you'd have to do 5 minus 9. You get 2 negatives, which makes it back to a positive. So you'll get the same answer. Here, 78 minus 46 is, I think, 32. And 9 minus 5 is 4. And these are nice that they turn out to be whole numbers. So 32 divided by 4 is 8. So at this point, we know in the equation, the format, this is the format we're looking for, y equals mx plus b. We know that that m is 8. So let's go ahead and put that in. Y equals 8x plus b. Now, how do you get this b right here? That's the last thing we need to get this equation. Well, there's formulas for it, like a point slope formula. But the way I get it is I just substitute in one of the points and solve it. It doesn't matter which point you use. You'll get the same answer no matter which point you use. So I'm just going to pick this one because it's smaller numbers. There's an x and a y. I'm just going to substitute those in. So I get 46 equals 8 times 5 plus b. So when you work this out, I'll just go here to work it out. You get 46 equals 40, because 8 times 5 is 40, plus b. And subtracting the 40 from both sides, you get b equals 6. So that means that the entire equation is y equals 8x plus 6. That's the answer to this problem. And you can check it by substituting in the values for x to see if you get out the y. Like, for example, if I substitute 9 in there for x, I get 9 times 8 is 72, and 72 plus 6 is 78. It works. You can check this one. Put 5 in. 5 times 8 is 40. 40 plus 6 is 46. If it works with both points, that's the answer for sure. So you just type that in. 8x plus 6. So not an application problem, but it's just, that's a procedure there. This is the same thing. Here's problem 6, same thing. Get the, oh, this one just wants the slope. So all you have to do on this is just do the first step, get the slope. So let's take a look at 7. On 7, they just want the slope of this, but they're giving you a graph. So what we can do with this is pick out 2 points that hit right on the crosshairs. But I mean, like they hit right where the crosshairs are on the horizontal and the vertical. Like if you look at the graph that I have here, we can see that this has a lot of different points that hit right on the money. Like, for example, I see there's a point at 0, -4, which is the y-intercept right here. I could use this x-intercept if I wanted to. I wouldn't have to. I just need 2 points. So another point is this point, 4, 0. And I'll just get a couple other points you can see. Like here's one at 6, 2. We only need 2, but I'm just showing you there's a lot of points you have to choose from. And wow, that didn't write well. 6, 2. Here's another one down here at -2, -6, -2, -6, right here. -2, -6, hits right on the money right there. Well, we only need 2. So let's just use these and get the slope. So then just use the slope formula. That's it. So slope would be, how much does it change in height? Well, I'll subtract in the same order. I'll go from -4, this one, -0. So I did the y values subtracting in this order. So I got to subtract the x values in the same order. 0 minus 4. See, I went from this one. In the y's, I went from -4 to 0. So I had to do -4 minus 0. And since I went that way with the y's, I got to go in that same order with the x's, 0 minus 4. If I work this out, I get -4 over -4. And anything divided by itself is 1. So the slope is 1. So a positive slope should be going uphill. So if I made a mistake and I got a negative, I know it's wrong because this line is going uphill. So the slope is 1. Okay. So I think this one's from Pinocchio. Here, this one. So on 8, it says, Geppetto is a puppet maker. On the 7th day of the month, Geppetto had 86 puppets. So on the 7th day, he had 86 puppets. Then on the 13th day, he had 158 puppets. So what is his rate? Puppets per day here. So we'll subtract, take 158 puppets minus the 86 and divide that by the 13 days minus the 7. So what we get here, this would be, I think, 72 over on the bottom. I think that's 6. So just doing some subtraction there, divide that, you get 12. So his rate is he's making 12 puppets per day. Right there. So now it's a weird question. How many does he make every 4 days? So if he makes 12 puppets per day, in 4 days, he makes 4 times 12 or 48 puppets. So because he's making 12 puppets per day. Then this part here, part C of this, says how many puppets are ready to sell on the 17th day. So we're looking for, on part C here, we're looking for the 17th day. Wow. Okay, well, look at this. Here's day 13. So we know this, on day 13, he has 158 puppets. And we know it's going up by what? 4 puppets per day, right? 4 puppets per day. Or we know this, how many in 4 days? 4 days, we already know in 4 days, he'll make an additional 48 puppets. Now, why is that helpful? Because 4 days on to 13, day 13, plus 4 more days gets you to the day we were looking for, day 17. So if we just add these up, we get 206. And that's how many puppets he would have on that day, 206 puppets. That's a pretty good problem there. So do you see how we got the slope? Then it says how many in 4 days. Then the 17th day is 4 days after that. So we just had to add what we had at day 13 onto 4 more days. So it's a little bit of problem solving there. And we can get a similar problem on this one since it's tough. So look, we'll do this one. Let's do a second try at problem 8 so you can have 2 examples of that. So here's 8 again, because it's a pretty tough one. So again, same situation. On the 8th day of the month, he had what? 50 puppets. And then on the 11th day, he had 68. And so we want his rate. Subtract these 2, subtract them, and you get 18. subtract these two, and you get 3 days. 18 puppets in 3 days, divide, that's 6 puppets per day. Okay, how about every 6 days? So this is part A. Part B was in 6 days. How many does he make every 6 days? So every 6 days, he makes 6 times the 6 puppets per day. In other words, he makes 36 puppets in 6 days. And then part C says, how many puppets are ready to sell on the 17th day? 17th day. Well, look, 17 is 6 days after day 11. So again, we got, let's think of this, day 11, we got 68 puppets. Then in 6 more days, 6 more days, I'll just say it this way, 6 more days. Six more days. He has what, 36 more. So see, that gets us to the 17th day then. 11 plus 6 is 17th, is the 17th day. And we add these up, I think you get 104. So it should be 104 puppets. And if we got this one right, you can be sure that we got all the rest of the parts right. Yep. All right, that's a pretty solid example. These are the same type of thing, again with slope. So it says, what is Superman's average rate? So this is another ratio of how far he is from somebody. So we can take a look at it here. On 9, it says Superman needs to save Lois from the clutches of Lex Luthor after flying 8 seconds. So 8 seconds. He is 1,660 meters from her. Then at 13 seconds, he is 1,385 meters. Well, he's not flying that fast if it takes him that long to get there. So what's his average rate? Well, just subtract the distance and subtract the time and divide them. That's your slope again. So in part A, you're just getting the slope. So we take the 1660 minus the 1385 and take your time and subtract it in the same order. 8 minus 13. And that's a little odd because that's going to give you a negative. But up here, you would get, let's see, I think that's 255, I think. And I'm subtracting backwards on that. So that's actually a -5 right there, right? 8 minus 13 is a -5. So if we divide these, you actually get a negative, if I did my arithmetic right, I think a -51. Now, a rate can't be negative. The only reason that this is negative is because his distance is reducing. He's getting closer to it. So probably would have made more sense if I would have subtracted these and got a -255 over 5, meaning that his distance is dropping by 255 meters every 5 seconds. So as long as I did my arithmetic right, this one is actually 51. And again, it's not negative because it's a rate, a speed. You can't go in negative meters per second or negative miles per hour or whatever. It's just negative when you work it out because you're getting closer to something. So that's all that's going on there. Then how far does Superman fly every 6 seconds? We'll just take that value and divide it by 6. Now I'm hoping all my arithmetic is right here. I've been doing that in my head. So I think that's 215. That might be, I'm going to use a calculator to double check the arithmetic here real quick. So let me take the 1660 and subtract off the 1385. If I do that, it's 275. So I thought I might have had a mistake here. So that's 275 right here. So let's correct that. So that is right here, 275 over -5. And if I do that division, I think you get -55. So I believe this, and again, it can't be negative because it's a speed. So then every 6 seconds, just multiply this by 6. So 6 times 55 is, I think, 330. And then how close to Lois is Superman in 19 seconds? So we can see in 13 seconds, that was given in the problem, he's at 1385 meters. And then that's going down because he's getting closer to Lois Lane by 55 seconds, 55 meters every second, or in other words, right here, 330 meters in the additional 6 seconds. So 6 seconds more, that distance is decreasing by 300 meters because he's getting closer. Just, you have to know what's going on here, that he's getting closer. So that gives us a total of 19 seconds, but his distance has dropped down to 1,085 meters. So this right here should be 1,085. Okay, so let's see if we got all the parts to it, and missed that part right there. 1,085. Oh, 330 is what I'm supposed to be subtracting here. So typo right here. 330 meters is what we should have right here. 330. And when we do that subtraction, let's do that subtraction again. So doing that subtraction, we get, I think it's 1,055. 1,055. So let's go ahead and put that in. And there we go. Okay, so let's see what we got going on here with problem 10. On 10, it says a company discovers that to produce X equals 770 new electronic parts, it will cost $67,520. To produce 970 new electronic parts, it will cost $82,720. Compute the slope of the cost and choose the most accurate statement of the following. So we'll have to work it out. So on 10 here, we're going to get the cost per item. That's the way that makes sense on this. So it even tells you what the X and Y's are. So what we'll need to do is take the 82,720 items and subtract off the $6. Sorry, that's the cost on the top. 67,520. So that's your cost is on the top. See, this is where your cost is. And the same order, we have to subtract off the number of items. So the 82,720 was how much it cost to produce 970 of these items. And the 67,520 was how much it cost to make 770 of these items. So this was the number of items. And the reason why we're doing it in that order is because you get cost per item when you do this. So that's just a mess to do that subtraction there. I know we have 200 on the bottom. On the top, I'd like to be able to do that in my head. I think that's 5,000. Let me see. 15,200 maybe. 15,200. Probably doing that division too quick in my head here. But I think that might be right. And then when you divide that, I think you get about 76. I'm just doing this. Don't want to waste your time with watching me use a calculator. So the cost is actually $76 per item. So let's see if we got that. So, and it is a positive. So it would be going up. Costs are increasing. Let's see, $76 per item. I believe it's this one right here. Costs are increasing at a rate of $76 per item. That's it, because it's positive. If it would have been negative, it would have been decreasing. All right. This is the same type of thing as the previous problem. Work out the slope and then say which one it means down here. This is a population in years. So the population, if we take a look at it, is it going up or going down? Wow, it's hard to tell. It's changed very, very little. I think it actually went up slightly, very, very slightly. So I think it went up, increasing at a certain amount of people per year. So you just work it out like we did the last problem. This is another one with the slope, like the Geppetto puppets and so many other ones. You have a time variable. So you just set it up the same way as we did the others. So let's see. Suppose you're driving, you notice that after driving 2 hours, you are 115 miles from Seattle. So let's see, 2 hours, you're 115 miles away. Then you continue driving and calculate that after driving 9 hours, you're 465 miles away. Again, notice that you're using the time variable is the X variable, and the other variable, whatever it is the Y variable. Then you can work out your rate. So again, it's 465 minus the 115 over, now subtract off your X values, your time, and the same amount, 9 hours minus 2 hours. So on the top, doing that subtraction, I get 350. And on the bottom, I get 7. And that division gives me 50. So you're going at 50 miles per hour right there. And then how about every 5 hours? We've done several of these. So 5 times 50 is 250 miles. And then how far are you in 14 hours? Well, look, here you are in 9 hours. In 9 hours, you're 465 miles. So in another, what do we figure? Right here, in another 5 hours, you're 250, right? So 5 more hours, you've gone an additional 250 miles. So when we add these up, we get a total of 14 hours. You traveled a total of, I think, 715 miles. Let's check in my arithmetic there. I think that's 715. All right. So you can always pause these. You know, if you watch the video on this, you can always pause it. Okay, let's check this one. On 13, so in 13, it gives you a slope. The slope, which is labeled M, is -3. And then it also gives you a point. The point is -3, -4. So what they want is the slope, where M is what? Well, it gave you. The slope is -3. Now, what's the B in the equation? So this is the one like we did earlier where you have to actually calculate the B. So right now we know this is the equation, right? It's going to be in the form y equals mx plus b. The m is -3, so it'd be y equals -3x plus b. How do we get the b? Substitute the -3 in for x and substitute the -4 in for y. So if we do that, we get -4 equals -3 times the x, which is also -3 plus b. So now we just have to work this out. So we get -4 equals 9 plus b. Subtract 9 from both sides, and you get b equals -13. So that would be your b right there, -13. And just to check it here, I'll show you what I mean. You have an equation then. The equation would be y equals -3x minus 13. You can check it. If you first of all, you know the slope is -3, the slope is -3. And if you substitute in -4, well, look, if we substitute in -3 for x, do we get -4 for y? Well, I think you do, because if you substitute in that -3 and for x, if you work this out, you'll get 9 minus 13, which is -4. So it works. That was just a check there. So this one is wanting the equation. So if I look at this point, this graph here on 14, let me see if I can get this on. No, I have to go down here. So on this problem, just looking at the graph, so some of these don't have, well, this one does have a written example, but it may not show the graph on the written example because it's hard to get those graphs to show up on a written example. So here on 14, first of all, you can see the y-intercept. The y-intercept showing in this graph is at the point 0, -2. It's right here, 0, -2. Now to get the slope, we can kind of count it up. So let's see what we got. So let's look at 2 points here. Here's 1 point. We'll use this point, 0, -2. And another point on this graph, we're looking for where it hits really nice here. Well, there's a couple spots. One is right here at the point 2, -8. There might be another one you could use, like up here, there's a point at -4, 10. There's also a point here at -2, 4. Using any of those as a second point will give you the same answer. So the slope, again, is how much it rises. So that's these two subtracted. Subtract them in any order you want. I'm just going to do -8 minus a -2. But since I subtracted the y's in that order, I got to subtract the x's in the same order. So 2 minus 0. And if I work this out, -8, 2 negatives make them positive, so it'll be -8 plus 2, which is -6. And on the bottom, 2 minus 0 is 2. And -6 divided by 2 is -3. So that means that my slope is -3. I already have my b. The b part of the equation is the y-intercept. So that's -2. So my entire equation is, remember the format, y equals mx plus b. So my equation is y equals -3x minus 2. That would be the equation right there. Because the slope is -3, that's the number that goes before the x, and the y-intercept is -2. So we can just type that in there. -3x minus 2 should do it there. So these you might need to refer to this video or the videos that are sitting there. Like to me, I like the videos and the written examples I think are ones that people use the most. Same type of one we did for several problems. I'll go ahead and do it since it might be tougher than ones that we saw before, but they're very similar to like the Superman problem and the puppet maker and all that sort of thing. So suppose you're driving, you notice that after driving 3 hours, so let's just keep track of this. See, I'm always doing a time variable on the left-hand side. 3 hours, you've driven 175 miles. And then you continue driving, calculate in 8 hours, you've driven 425 miles. Then what is your rate? Well, subtract these, right? We'll take the miles driven, 425 minus 175, and divide that by your change in hours, 8, in the same order, 8 minus 3. So up here, that's 250 over 5, which is 50. There's your speed, 50 miles per hour. And then, so this is a 50 right here. Now this looks a little different. The how far from Seattle did you start? Okay, that's going to give you your like y-intercept here, because it's at the y-intercept is what it was at the start, like the whale, the very first problem. What was the weight of the whale at birth? That would be the y-intercept. But this one doesn't give you a y-intercept. You've got to get the y-intercept. Well, how could I get the y-intercept? Well, we could back it off. We could think, okay, this is 50. He's going 55 miles per hour. So if we want to get what it was at the start, we could say, well, we got to back off from this one, 3 hours of driving 50 miles per hour. Well, 3 hours of driving 50 miles per hour is 150, and 175 minus that 150 would be 25. And you know, there's nothing wrong with doing the problem that way. But I look down here and I see they want the equation anyway. So I'm going to go ahead and get the equation on this. This is the slope, is what I just figured out here, which is again the m on the y equals mx plus b. So at this point I have y equals 50, that's my slope, 50x plus b. Now how can I get that b? Well, if it's not given to me, the y-intercept, then I can substitute a point in. So I'm just going to use this point here. You can use the other one if you like, but you'll get the same answer. So on this one, the Y is 175 equals 50 times the X value, which is 3, plus B. Well, when you work this out, you're going to get the same thing I just typed here, which is 25 miles. Watch, we'll show you here. You get 175 equals 150 plus B. And if I subtract the 150 from both sides, I get B equals 25. That tells me he was 25 miles from the start, I guess Seattle, when he started. So he didn't start right at Seattle. He started 25 miles from Seattle. So we did it with algebra, but here we did it kind of thinking our way through, right? If you want to get it from the start, here's 3 hours in. We know the speed is 50 miles per hour. 3 times 50 is 150. And if you take that off of the 175 miles that he traveled, that he's away from Seattle in 3 hours, so 175 minus that 150 is 25 miles that he's from Seattle. And here's just working it out. So now what's that equation? Well, in terms of Y's and X's, it'd be Y equals 50X plus 25. But notice they say to use D and H, stuff like that. So distance is D, H for hours. So his distance that he is from Seattle is 50 times the number of hours that he's driven plus 25. So that's what they want for the last part. And really, I could have got that without working all this out because I figured out that 25 was just using some common sense on it. So just type that in, D equals 50H plus 25. And that's all you have to do there. Oop, didn't get that quite typed in right. 50X, 50H plus 25. Here we go. Same type of thing with the elves here again. So notice here at the end, they want you to do the same thing with change your variables around to minutes and N for number. And, just to have it complete, unless you guys want me to skip it, I can do it just to have, so that you have a record of it. And we got, plenty of time, I think, to finish all these problems. So let's go ahead and do it. So on 16, we got at this time, so here we go, just keeping track at 12:12. There's 345 action figures ready. Then at 12:26, 12:26, there were 695 action figures done. What's the rate? Okay, so the rate is the slope. Again, remember they use M for slope. So we need action figures on the top. So how many action figures were made in this period of time? Well, 695 minus 345. And how much time is going by? Well, subtract the time in the same way. I don't really need to say 12 o'clock. That's not really changing. It's just the minutes. 26 minutes minus 12 minutes. So doing this subtraction here, I get 350. And on the bottom, when you do this subtraction, you get, I think it's 14. And 350 divided by 14, well, I think that's 25. Yeah, that's 25 right there. So your M, your slope, is 25. What does that mean? That means that he's making 25, these elves are making 25 action figures every minute. See, that's what we did when we worked it out here. This is action figures, and this is number of minutes. Action figures per minute, 25 action figures per minute. Now, it's just like the last problem. It's backdating it to 12 o'clock. How many action figures did they have already made at 12 o'clock? You might think none, but you're just assuming that they started at lunchtime, and nobody said they did. So what we could do is we could use the common sense thing and say, hey, he's making 25 action figures every minute. So in this 12:12 period right here, at 12:12, you are 12 minutes after noon. So that means for these 12 minutes, they made 25 action figures each minute for those 12 minutes. That's 300. So if you want to know how many there were at the start, you can take how many there were at 12:12, the 345, and subtract off the 300 that they made from 12 o'clock up to 12:12. That means they started off with 45. So you might need to watch that a couple times to understand that, but I'll say it one more time. We know there's 345 at 12 after 12. We also know that this is the rate now, 25 action figures per minute. Well, how many minutes are we past 12 o'clock here? 12 minutes after 12 o'clock. So each one of these 12 minutes, each one of these minutes, they're making 25 action figures. So to get how many action figures were made from 12 o'clock up to 12:12, just multiply these together. 12 minutes times the 25, that's the rate, you get 300. So if I subtract the 300 that were made from how many are made at 12:12, 300 from the 345 gives me that you must have had 45 action figures at that time. Now, really, I don't need to work that algebra out then if you could do this. In fact, that is your B, your Y-intercept. So we have both parts of the equation. The equation would be Y equals 25x plus 45. Now, in terms of your variables here, it says let M be for minutes and N be for the number of action figures. Well, you can see that this is the number of action figures here, which is like in the Y position, and your minutes are right here in the X position. So I'm going to, that N for number of action figures goes right here where the Y is. N equals 25 times the number of minutes plus 45. And that would actually be the answer to that problem. Now, the other way of getting that 45 is to use that where you substitute in a point in. See, like where we have Y equals, we have to get this part here, the slope. So we have Y equals 25 X plus B. And if you want to use algebra to do it, you have to substitute in a point. Well, what point could you substitute in? Well, see, they're saying 12 o'clock is your starting period. So you don't substitute in a time like 12 hours and 12 minutes. You substitute in just the 12 minutes for X. So I would say the Y value of 345 equals 25 times 12 plus B. And if you work this out for B, guess what? You're going to get the same thing, that the B is equal to 45. And again, the reason why I don't use all the time, the 12, I only use a 12, is because they're saying that we're dating it back to 12 o'clock right here. It says minutes after 12 o'clock. Well, 12:12 is how many minutes after 12 o'clock? 12 minutes. So that would be the equation that you type in. How you do it. And I don't want to, and that's a good thing for you guys to know as being teachers. You don't want to tell your students how to do a problem, like to show them or have them think it through, and then they can come up with different ways of doing it. Here's an algebra, here's thinking it through. And a lot of people are better off at thinking it through than doing the algebra. Plus, there's a lot of people that can do algebra that can't think through a problem. So it all depends on what way is good for you in that. Okay, guess what? More of the same here. Okay, more of the same. So I think you've seen a lot of these, but you know what? I'm looking at this one. I don't see a linked video to it. So I'll do one right here. So here on number 17, we got this it's the states and number of days, right? So this summer after traveling for 2 days, so we keep that as your X value, number of days, any type of time thing. 2 days, he visited 13 states. And then at 5 days, they made it to 28 states. It's always tough to get in Alaska and Hawaii, really hard to drive to Hawaii. So at this point, you get the slope, the rate, which is the slope. That would be states per day that they saw. So if we work this out, that would be 28 minus the 13. See, this one you could almost do in your head here. And on the bottom, 5 minus 2. If you work that out, on the top you have 15 over 3, which is 5 states per day. 5 states per day, right there. And they give you the units. Dustin's rate is 5 states per day, 5 per day, 5 states per day. Then that was part A. The next part, how many states did Dustin start this summer with? Again, see, that's giving you, once you're starting with, how much you start with is your B, your Y-intercept. So look at this. Up here, we know at day 2, he was at 13 states, 13 states. And we know he sees 5 states per day. So all we got to do to get this is back it off a couple days. If we back it off one day, go down to day 1, back 5 off of this, he was at 8 states. And at day 0, which is the starting time, he was at 5 off of this, 3 states. It's like if you wanted to go see every state in the United States, you wouldn't have to probably go to Maryland or Virginia or maybe a couple other states because you've already been there. So at the start, you've already been to some states. So you don't have to go to those. That's like your initial amount, how much you're starting off with. So anyway, at day 0, he's at 3 states. So guess what? That's your slope. That's your M is the 5, and your B, your Y-intercept is 3. So your equation is just Y equals, here's your slope, 5 states per day, 5M, sorry, 5, I'll just say X for now, 5X plus your Y-intercept, which is 3. Now they want you to use certain things like D for days and S for states. So the number of states, S, is equal to 5D plus 3. And that's what you would type in there at the bottom. And again, you could have gotten that Y-intercept of 3 by using algebra if you wanted to. You could have said, okay, well, we have this equation, Y equals 5X plus B, and we need to get the B. So substitute in an easy point up here, like 213. 13 is the Y value. 13 equals 5 times 2 plus B. What's the B? Look, 13 equals 10 plus B. B must be 3. Boom, same thing. So there's your equation. S equals 5D plus 3. Yep, good stuff. So again, get an equation on this thing. So we can type it in here. Let's see if we can just do this here. Y equals, let's get the Y-intercept first. Okay, I know it has to be in this form, mx plus b. I'll just write it in here. The b is the Y-intercept. Look, you can see that's 4. Now the tough bit is getting the slope. So we got to count to get the slope. So from this point to get to the next point that it hits nicely is right here. So what did we have to do? We had to drop 4 and run 2. So drop 4 is -4 and run 2. So over 2. That's all you really need right there. You can just count it up. It doesn't say it has to be reduced. Let's see if it takes it. It does. -4 over 2 is the same as -2. So if we would have just typed in, we didn't have to, but if we would have just reduced it and said -2x plus 4, you see that that is the same answer. And by the way, you'll get any point on this line with this equation. Like for example, this point here at -2, 8. If I put -2 in there for x, I will get 8 because -2 times -2 is 4 and 4 plus 4 is 8. It works. So, all right. So this one here at 19 says the graph shows your distance in miles from the Quickie Mart in relation to the time in hours that you've been walking. Time is on the x-axis right here, and distance is on the y-axis. Write an equation to model this situation where d is the distance and h is the time. So again, we want something instead of y equals mx plus b, our equation is going to be in the form of d equals something m, the slope times the number of hours plus b. Well, the b is the y-intercept, and just looking on this graph again, you can see the y-intercept is 6. That value of the y-intercept means that at 0 hours, he's 6 hours from the Quickie Mart, or 6 Yeah, I think 6 hours. Or no, at 0 hours, he's 6 miles from the, yeah, let me see here. Yeah, at 0 hours, he's 6 miles. At 0 hours, he would be 6 miles away. Now, what's going on with his distance? He's walking towards the Quickie Mart because the distance is, which is on the y-axis here, is dropping. You can see that he gets to the Quickie Mart in 2 hours. Because why? Well, right here, that coordinate is 2, 0, meaning in 2 hours, his distance is 0. See, the height represents the distance from the Quickie Mart. So in 2 hours, he gets there. So let's see what the slope is. He's walked 6 miles in 2 hours. Well, we can put it in like that. So his distance has dropped by 6 miles every 2 hours. Now I know that -6 over 2 is -3. And if we have to, we'll put it in like that. But you see, they really don't care about the fraction stuff. So again, you would get it right whether you typed it in like this, or if you typed it in -3, because -6 over 2 is -3. Either way, it's right. And you can check it. You know, do you get a point here? Let's see, I don't know, another point that shows up nicely. And this one doesn't really make sense. At 4 hours, he's -6 miles away. That doesn't make sense. So really the only part of this graph that makes sense is just this little bit right here from 6 to 2. That makes sense. So anyway, that's how you do it. Again, you see the y-intercept, bam, put it in there. Then the slope, just count, down 6 over 2. Down 6 makes it negative. That's where the -6 over 2 came from right there. I like those real life problems because you really can see how it works, you know, rather than just numbers. Okay, on number 20, it says on a bicycle, Heather rides for 5 hours and is 47 miles away from her house. Okay, so let's keep track of some points here. So 5 hours, again, we keep time on the x variable in a coordinate. 5 hours, she is 47 miles. See, time on this side, that's hours. And here's miles right here. And then after riding 10 hours, she is 92 miles away. Write an equation to model this situation. Okay, so generally thinking it's y equals mx plus b. We got to get the m. The m is the change in the y values. So the m is going to be 92 minus 47 over the change in the x's, or the hours. Subtract in the exact same way. We do 92 minus 47, we got to do 10 minus 5. So working these out, up here during the subtraction is 45, and down here is a 5, and doing that division you get 9. So at this point we have y equals 9x plus b. How can we get this b? Algebra or common sense type of thing. Like he's going 9 miles per hour, and if we had to back it off to get down to 0, which is what the y-intercept is, how far you were away at the start, well, looks like in 5 hours he would have traveled 45 miles, right? 5 times 9, 5 hours at 9 miles per hour. See, this is miles per hour. So 9 times 5 is 45. Take the 47 minus 45, the b is 2. If you can't figure that out, then just substitute in a value. Right, here's one, just substitute it in. 47 equals 9 times 5 plus b. So that's 47 equals 45 plus b. So the b, 47 equals 45 plus what? 2. Subtract 45 from both sides. So your equation is y equals 9x plus 2. Again, they are changing the letters for you over here. It's hours and miles. Miles is the y variable. So this is my miles right here. That's 9 times h for hours plus 2. So that is what I would type in to that. And I'll let you guys do that. 21. I think it's the same type of thing here going on. It's the number of states per day. And I think that's exactly what 20 was about if we back it up. Wasn't it? No, that was That was writing, but I think we already did one with states. But since there's no linked video, I'll go ahead and do it here. So 21, we have this, 2 days. And 2 days, see, this is days, the time variable. In 2 days, 15 states. This is number of states here. And then they give you again 4 days. They were at 27 states. Okay, so we need the whole equation here. Got to get the slope. So we'll take our 27 minus 15, and on the bottom, same order of subtraction, 4 minus 2. Here you get 12 over 2, which is 6. So she's visiting 6 states per day. And then to get the y-intercept, again, 2 ways of doing that to get the b. We could just back it off 2 days, 2 times, we could take 2 times 6. See, the 2 days at 6 states per day gives you 12. So if we take the 12 and subtract it from the 15, 15 minus 12, that means at day 0, she was at 3. That is your y-intercept. See, day 2, she was at 15. She's seeing 6 states per day. 6 times 2 is 12. 15 minus 12 is 3 states that they saw to start off with. So the equation would be y equals 6x plus 3. We might have to change our letters around. And again, to do it by algebra, after you get the slope, and you have the y equals 6x plus b, you just substitute in a point. So 15 equals 6 times 2 from the 2 days plus b. And if you work that out, you'll get b equals 3. So that would be the equation. And they want S for states equals 6 times the number of days plus 3. I think, oh, we don't want X there. Days, I think they want D or something like that. So here we go. And this one, let's see what we got on a bicycle. Looks like we got a little bit of a code problem here, but I'll check that out on 22 and see if anything needs corrected on it. So on 22, on a bicycle, Patricia started 4 miles from her house. That's your y-intercept. At time 0, she was 4 miles. And she rides at 8 miles per hour. Guess what? That's your slope. 8 miles. It's a rate, you see, 8 miles per hour. At 0 hours, she was 4 miles from her house. See, if I was graphing this, that's a y-intercept. Here's your time variable here. And here's your miles on this. So at time 0, hours 0, she was 4 miles away. Right here, right there. Then she's traveling at 8 miles per hour away from her house. So every hour, that's going up by 8. See, so at 1 hour, she'd be clear up here at 12, 8 miles more. But anyway, that's the equation. Y equals, there's your slope, 8x, whatever the x variable is. In this case, it's hours, plus the y-intercept, boom, 4 miles. So switching over to the variables they want to use, d for distance equals 8 times hours plus 4. So at hour 0, if you put in 0 for h, you get 0 times 8 plus 4 is 4. She is 4 miles away. How about in 1 hour? 1 times 8 is 8. 8 plus 4 is 12. I'd be up here somewhere, a little bit too high for me to graph on this. But the equation is right there, what I got. D equals 8h plus 4. Let's see if it takes it. Yeah, must be just a little answer type I need to put in there. So on this one, on 23, it just says you started this year with a savings account of $468. So see, that's the start of the year. I don't know if we're, I should read the whole problem before I do all this, but that's how much money. Then you save $27 per month. So $27 per month. Well, guess what? It's just like the last problem. Here is the y-intercept. Y-intercept there, because it's 0 months at the start. 0 months. This is the amount of money that you got, $468. And then you continue to save, adding on to it $27 a month. That's your slope, is right there. So your equation would be y equals 27x plus your y-intercept of 468. See, if you think about it, well, here, let's put in the variables that they want. Your savings, y, so I'll just use s for savings like they said to do, 27 times the number of months plus 468. So, for example, how much do you have saved at the start? It says $468 right here. That was given in the problem. But this equation gives you the same answer. If you put in 0 for the number of months, you get 468. How much do you have to saved in 1 month? Well, 1 times 27 plus 468. How about 12 months? Put 12 times 27 plus 468. That's how much you saved. So that's what that equation gives you. It gives you any amount over any amount of time that you have saved. So 468. And that should do it with that one. All right, let's see this one. This is something about, geez, 20,000 legs beneath the sea or something like that. Oh, Alvin and the Chipmunks. If you remember them from some sort of Christmas things. If you haven't ever heard the song Alvin and the Chipmunks, then you can probably YouTube it. Okay, 24. After visiting the Titanic, Captain Brian and Mr. Pinky are taking the Alvin submarine back to the surface of the water. They started, see, that's where they started at time 0. They were at 1900 meters. So here's your time at time 0, and here's your meters. So at time 0, they were at what? 1900 meters below the surface. Okay, let me take care of this here a second. So then in ascend 38 meters per second. Now, the only thing that gets me here is that they're 1900 meters below the surface. So what I'm going to change that to, since they're below the surface, is I'm going to change that to a negative 1900 because they're below the surface. So this is a negative 1900. And then what are they doing? They're going up. They're ascending, going up 38 meters per second. So their slope is 38 meters per second. So what we got here? So the equation is y equals 38x minus 1900. Now they say to use certain things, d for depth. The depth is equal to 38 times the number of seconds, t for time, minus 1900. So that would be the equation there. And you just type it in, d equals 38t plus, minus 1900. So that should work out good on that one. And then see, with that equation, you say, like, when will he make it to the surface? Now they don't ask that, but when he makes it to the surface, the depth would be 0. It would be right on the surface. It won't be above, it won't be below the water, it'd be at water level. So you just say 0 equals this, and you could solve it. So you can solve off anything there, like when is he 1,000 feet below? So negative 1,000 equals this, and then just solve it. So, okay. So on this problem here, 25. So here on 25, kind of weird wording, it says, suppose that 5 weeks ago. So that sounds like, if it's 5 weeks ago in the past, it sounds like I should be calling it -5, 5 weeks ago. Stock KMS was at $55 per share. So here's its value. So again, we got time here and maybe value or dollars here. And actually, I'm looking ahead at what letters they say to use. And for time, they're using weeks on this one. So let me put that in. So here's my W, number of weeks, 5 weeks ago. and it's dollars is what they're using there, $55. Then 3 weeks ago, so here's 3 weeks ago, I'll say -3 because it says ago, like in the past, it was worth $51. That's not good because its value is going downhill. So like, do you want to keep this stock or do you want to sell it? So what we want to do is write an equation for this, what's going on. So again, we'll have to get the slope. So to get the slope, we'll get the change and the dollar values. So subtracting these in some way. And since I'd like to deal with positive numbers, I'll subtract the 55. I'll take 55 minus 51. You don't have to, but it's just easier subtraction. But now I got to subtract on the bottom. I have to subtract in the same order. And that's never fun here. -5 minus -3. So if I work this out, 55 minus 51 is 4. And on the bottom, -5 minus a -3, again, two negatives make a positive. So -5 plus 3 is -2. So if I do this division right here, that makes a -2. What does that slope mean? It means that your stock is going down $2 per day. If you check here, it went down $4, right? 55 down to 51, that's going down $4. And it did that in 2 weeks, right? 5 weeks ago, 3 weeks ago. So it went down $4 in 2 weeks. So that's the same as right here, a slope of -2 when you divide it out. So now what we have to do is get the whole equation, get the y-intercept. So at this point, we have this equation, y equals, or if you want to use the letters they're using, let's go ahead and use the letters they're using right off the bat. They're using D for dollars. So the dollar value of this stock is equal to the slope, -2, times the number of weeks plus the y-intercept. So I got to get this y-intercept. So the y-intercept is going to be at time 0, week 0, which is actually 3 weeks ahead of this, right? Here's -3 weeks. So to get to week 0, we got to go 3 more weeks. And for each week, it's going down by $2. 3 times -2 is -6. And if we take that $51 that it was worth 3 weeks ago, and we subtract 6 off of it, I get 45. So I think that's your y-intercept, but let's do it with algebra here. So using algebra, I just substitute in one of these points into here. So let's do this one. 55 equals -2 times the week value, -5 weeks, plus b. Working this out, you get 55 equals 10 plus b. And subtracting the 10 from both sides, you get 45. So I would say that's it right here. The equation is D equals -2w plus 45. So we'll see if that got it. Yay. Okay, I think we only have like 2 left here. Nope, got like 4 left here. So let's take a look through them. On 26, so the mother gives birth to a 7-pound baby. Okay, so here's 26, gives birth to it. So that's just born. How much time has gone by? 0 months, right? That's a y-intercept then. At time 0, the baby weighed 7 pounds. That's a y-intercept. You'll get better at identifying. That's the start value. Then look at this. Every 2 months, the baby gains 5 pounds. That's a slope. So gains 5 pounds every 2 months. Remember, it's rise over run. And that's, what is it? Months here. Rise over run. And we're running, when we run along the x-axis, if there's a variable of time, that's on the x-axis. This is the time. See, slope is rise over run, and you're running along the time axis. That's how I knew to put the 2 months at the bottom right there. So my entire equation is given to me. It's y equals 5. In fact, yeah, they don't say to use any special letters here. 5 over 2x, 5 halves x, plus 7. That would be your equation right there. If you substitute in 0 for X, 0 months, the baby weighs 7 pounds. How about in 2 months? Well, in 2 months, see the 2's would cancel out. So you just get 5 plus 7 weighs 12 pounds. It makes sense because every 2 months, the baby's gaining 5 pounds. So the baby would be at 7 pounds. Then what? 5 on to that, 12. Then 5 on to that, 17. Then 5 on, 22. So anyway, that would be, you can see how it actually gives you answers that make sense on that. Although it seems like a pretty big baby going up in weight that quick. So this one's giving you an x-intercept and y-intercept on 27. What's the equation? So on 27, you have a x-intercept at 0, -9, and you have a y-intercept at, let's do this one more time. That x-intercept, remember the x-intercept gives you the x value. So the x value is -9, 0. This is why you got to be focused. I was thinking about something else. So when you do your homework, you want to not be thinking about other things if you can help it. 0, -3. So now you just use your slope formula. So the slope, how much rise and run did it do? Well, we'll subtract off these y values, -3 minus 0, and subtract off the x values in the same order. 0 minus a -9. And if I work that out here, -3 minus 0 is -3. Minus a -9 is 9. And that's -1/3. So my slope is -1/3. And my y-intercept was given to me right here. So the equation is y equals -1/3 x minus 3. I'll go ahead and put that in there. -1/3 x minus 3. And this one, we can do this one right here. I want to get the equation for this line. You can see its y-intercept is at -6. So I'll just type that in and I'll go over here and type in the slope. Well, the slope is down 11 and run 7. So that would be the slope of that line. So there's your y-intercept at -6. And here's your slope, down 11, run 7. That's it. And another one. So this last one here, let's get this one. So on 29, we have a clothing business finds that there's a linear relationship between the number of shirts N that can be sold and the price P it can charge. In particular, historical data shows that 3,000 shirts can be sold at a price of 20. So now, if you notice later on with this, you see the P, and when it gives you the equation, the P for the price is in the Y position right here, and the number of things sold is in the X position. So I know that these points need to be coming in the format N, comma, P. Again, just like X, comma, Y. And the reason is because I see here the P is in the Y position of the Y equals MX plus B. See how Y equals MX plus B is solved for Y? This equation is solved for P. So P must be in the Y position and N is in the X position. So now the points, that the information they give me has to be in this form. So it shows that 3,000 shirts, the number of shirts, 3,000, can be sold if you charge $70 each, $70. And 24,000, wow, 24,000 shirts can be sold if you only charge $28. So we got to get this here. First thing is getting the slope. So that would be change in the price. So we'll do, so here we're subtracting the prices. I'll just do 70 minus 28. But if I do 70 minus 28, I got to subtract the X values in the same order. 3,000 minus 24,000. Well, let's see what we get here. Up here, I get 42. And down here, I get negative 21,000. So this one is an icky problem in terms of numbers. So what I would do on this case is use a calculator. So on this, I'm going to take, and this is the last problem. So this is the hardest problem. 42 divided by the negative. Let me see, where's my negative sign? I think just use this, negative 21,000. And I get this horrible number. So this calculator shows small numbers in this format, negative 2e negative 03. What that means, that negative 03 here means move your decimal point. This is just this calculator. It means move your decimal point 3 places to the left. So here's my decimal point. I got to move it 3 places to the left. So it'll really be negative 0.002. That's my slope. Okay, due to dividing by such a large number like that. So that's the slope. The y-intercept, well, again, this is the last problem. It's pretty messy. So at this point, I know that I'll just use it with y equals mx plus b. Y equals negative 0.002 x plus b. I got to get the b, so I substitute in a point. I'll substitute in 3,000 for the y equals negative 0.002. The x is 70 plus b. And now I just work this out. So 3,000 equals, if I take the 70 times that, I think I get negative 0. Well, I'm just going to make sure here. Let's do this. I think it's, if I multiply this times 70, I think I get 0.14. Yeah, negative 0.14 plus b. Yeah. And then add that to the other side. So I get 3,000.14 equals b. Wow. Okay. Oh, I see what I did wrong. That didn't seem right. So what I did wrong was I didn't substitute the right values in. Hold on one second. So you can see here that I substituted in 3,000 in for the y variable, but it's not. 3,000 is a x variable. So let's do this one more time from this spot. So here we go. We would say 70, the y value. So I think I'm losing it here. Negative 0.002 times 3,000 plus b. So let's work this out. 70 equals, let's clear this and do this. Negative 0.002 times 3,000 is negative 6. So that seems nicer. Negative 6 plus b. Add the 6 to both sides and you get b equals 76. So your equation then would be y equals negative 0.002 x plus 76. And you can substitute in a point and check it. But now they want it with, instead of y's and x's, they want it with p's and n's. So it'd be p, the price, is equal to negative 0.002 n, the number of shirts, plus 76. So let's go ahead and type that in here. And we would say p equals negative 0.002 n plus 76. And we'll submit that one. And we got it. And that's the last problem right there. So that's all of them. And maybe I'll try to put a link to each problem to this video and give the time that this particular problem, shows up so you can get to it quickly. Okay, so I'll stop there and I'll stop the share at this point, and I will stop the video at this point. So let me do that.